All right, so I've made a pretty significant change to our Aerodynamic Tetris game since last video. You can see here I've commented out all references to the list frozen squares. That's because I don't have that list anymore. I went to try to get the line clearing routine set up, and it proved really difficult to do with these frozen squares just kind of hanging there and supposed to move down, but then if they move down you need to check the same row again, etc. And it ended up taking a lot of computer time and a lot of brain power to try to work it out and understand what I had written. So I've commented these out for now, meaning right now it's not checking against squares that are already in place. I will add that back in using my new setup. The way I've set it up now, instead of the active piece sort of leaving itself behind, I've set up a grid of frozen squares that are always there. Let me show you what I mean. Here's a list grid. Starts out empty because that's an easy way to start a list in Python. And then here I loop over the entire playing field. So this is going from the bottom to the top. So we're going by rows, and then we go left to right, and then we go by columns. So if you can imagine it, here is the grid. Here's our playing grid. And basically what I've done is divided it up into squares. So here's the first row with, let's say, 1, 2, 3, 4 squares along this way. Then we have the second row, again with 1, 2, 3, 4 squares along this way, which we keep going up this way. And so those are numbered starting from this corner and then reading to the right and then going up. So this is square number 0, square number 1, square number 2, square number 3, etc. So this will become 4 and then 5 and then it goes on. And the reason I've done that, so these squares are always there. The difference is they start out invisible. And so what we're going to do, instead of having the active piece get left behind somewhere on this grid, we're just going to toggle these squares visible or invisible. And basically, if it's visible, then the square is there. If it's not visible, then there's not a square there, if that makes sense. And the reason I want to do it that way is because then clearing out these rows is just a matter of triggering invisibility on and off, basically toggling the invisibility. Try that again, Brian. Because then all I need to do is toggle the visibility of each of these squares on and off using this visible flag here. It's also nice because I know exactly where each of these is. I don't need to worry about, snapping them to a particular location. These do not move. And so in order to recall a square, in order to recall a point on the grid, I've made this function grid index, where you put in an XY position. So our block routine, the tetrads are moving according to some physics that is concerned with the X coordinate going along this way and the Y coordinate going along this way. And so this transforms this X and Y coordinate into which index it is in the grid list, because it's predictable, right? All I have to do is count up the number of rows I want and then count over the number of columns I want. And that's what this does here. We figure out what IX needs to be, how far along and how many squares in the X direction it is, IY, how many squares it is in the Y direction, and then the square index, since this is counting, this is not a two-dimensional array, this is a one-dimensional list, we just take IY times the number in the X direction and add IX to that, and so that becomes 0, 1, 2, 3. Now start back up over here, but you're starting from 3, so you have 4, 5, 6, 7. Start back up over here, we start with 8, etc. The difference being ours has, I think, 13 wide, so this should be 13 in the real code. And so the rest of the code, the actual animation part, works the same. We create an active piece, we make it fall down, and then when we're checking for whether it's reached the bottom, let me clear this. There we go. Now when we're checking for whether we've struck a square that's already frozen in place, here's what we do. We look along each row. So we're going to start with Y at the bottom, and we're going to go until Y gets to the top. Now I've set this up as a while loop instead of a for loop for a very specific reason that we'll get to in a second. And here we count the number of lit up squares along that row. Basically, the number of blocks that are quote unquote in the row, meaning how many of them are visible. So we go along X from the left edge to the right edge. This X is just going to increment forward unstoppably. So we're going to just use a for loop there. You could change it to a while loop if you really wanted to. And then we just increase the count if the thing is visible. It's convenient here. Python records true and false as 1 and 0. So you can add Boolean variables like this, true and false variables like this, and it will count them for you because false is 0, true is 1. So the number that are lit up gets counted in account. And then here's that NX we had earlier, the number of squares along the horizontal direction, the number of squares in each row. Basically, if count equals NX, we have a full row. We have a full row. Now we need to clear it. And so in order to clear it, what we're really doing is we're saying, okay, this row is gone now. The next row needs to come down. The next row needs to come down. The next row needs to come down. So really what we need to do is copy the on-off arrangement from the row above into the row below and repeat going up the playing field. So here what I've got is a different Y counter because I don't want to change this Y yet because I actually want to stay on this row because now I need to check the next row in case I clear 2 at a time. And so here I've got for Y prime in the range going from the current Y up to the top because I don't want to check below, I don't want to change things below that because those were not full. Then we move along here and basically we say, this is a long complicated thing, but this is where we use that grid index function because I know what my X and Y are. I don't necessarily know what my grid index is. I guess the more clever way to do this would be to just take the grid index and then add in X to that to get to the one above. But I feel like this is a little bit more robust. I don't know. I might change it to that later. But anyway, we take the grid visible setting and of this particular square and we set it equal to the square above. So this piece on the left-hand side is the same as this piece on the right-hand side. It's just we're adding 1 to Y prime. So we're looking up above one row and we're saying whatever this square above visibility is, do it to this square. And then we go up in terms of Y prime. So this thing is going to loop over Y prime till we get to the top. So that way it will copy all the visibilities down. And then the very top row needs to be cleared. So that's what we do here. We take the very top row, which is not going to be covered in this for loop since it doesn't go to the last value. And it will clear that entire top row. So it's going to set everything there equal to false. And now here's the trick. Here's why we want this to be a while loop. Now we've basically moved all the rows down. Now I need to check the next row. But the next row has become the current row. And so I don't want to increment Y. I want to repeat this while loop without changing Y, the latitude of the row that I'm currently working with. Now, if it doesn't come out clear, meaning if count is not equal to NX, if I'm not clearing that row, then I move up to the top. So eventually you do move up to the top. You just might have to repeat a few along the way here. And like I said, everything else works the same way. Let me show you how it works out in practice. Very happy with this. Let's see, I figured out the easiest way to get a full row is to move 1 over to the very left, then hit left twice, because I've had to test this several times, so I know how to get a row there. And then we move this all the way over. Then move this one over twice, and that's going to leave a nice upside down T shape right here in the middle. You can see the little shadow there. So we hit up twice to rotate this. This is going to come down. So I should have block, blob, block. Look, block, blob, block. That bottom row cleared out. So I'm very happy with that. Let me see. I figured out a way to get 2 rows to clear. Let me show you that that works. I believe you want to leave the left side blank. There we go. Cool. Okay, now I want to leave that as a spot where, so I need to go 1. There we go. And that's going to be the last spot that we fill in, I think. Okay, I need to fill in this spot here. Good. Need to fill in. Now I need to fill in this section here. Then this is going to be the last place I fill in. We're going to clear out 2 rows at a time to show you that that works. Boom. All right, I think that lines up. Yeah, so these two bottom lines are clear. I should have 1, 2, and then an L. 1, 2, and then an L. Woohoo! Okay. Can I get 2 more? Let's see. Now, a couple of things I'm going to need to address. Right now, so basically the active piece is going to here. It looks like the active piece is freezing here, but what's actually happening is that it's turning on the blocks that are in that exact same location and just turning the active piece to invisible, which I don't know that I want to do that long term, because that's going to continue. Oh no, I can't clear 2 here, because that's going to eat into the memory of the computer running. And so I need to find a way to quickly and easily delete those. I just need to look up the delete shape instructions. Okay, Brian, let's go back. Let's delete that part about trying to get a second one. Okay, so that's working out pretty well. There's a few things I need to adjust. I need to change it so that I need to do something with the active piece, because right now the active piece simply becomes invisible up here, and then it just kind of hangs out there in the computer memory. So I need to delete those. I just need to add a little script to delete them. The other thing I need to do, remember I commented out all of the checks for moving squares against each other. I haven't put that back in yet. That will be pretty straightforward to do. That's actually going to be easier to do now, because I don't actually have to loop over all of the frozen squares anymore. Now all I have to do is check for the space to the right or to the left, depending on which direction I'm moving. And so my little grid index function is actually going to make this faster in terms of computer time there. And then I learned I actually need to check for the rotations to make sure it doesn't end up off the screen or overlapping with another block, because currently there's no check on the rotations. So that's some technical stuff I will put in off camera. I'll also put in the other Tetris pieces off camera. So I'm going to do a bit of off camera work here. So you won't see another video about this for a little bit, but then after I'm done with all that, we can start putting the physics in. So thank you so much for watching. I will see you next time. Bye-bye.